With this tutorial I want to point you to the iterative solver in NX, which can be used to optimize your design intent during multiple iterative steps into a direction which will fit to the requirements or specified requirements. As example, I have taken the classical can problem, which gives you, I think, the easiest way to understand the logic of iterative solvings, and in German called Extremwertaufgaben. Yes, the can problem is very easy. We have a can, and we want to achieve a specific volume inside the can of more or less 1000 cubic millimeters by reducing the surface of the can, because this is a material we use to build the can, and the cost-effective parameter to reduce this to the minimum value which is possible. And that we want to achieve by varying the diameter and the height in an iterative way to come as close as possible to the optimal solution. This can be done with different tools like the Excel solver, but it can also be achieved directly within NX. This should be only a small example, but if you have a more complex geometric, you can achieve it in a similar way. Therefore, I've created a simple feature, a cylinder feature as can design, and have named the two feature parameters to make it easier to identify them later on in the process. On the analyzers menu, there is an optimization and sensitivity tool called optimization, and this is, from my point of view, one of the very powerful tools to run through different design studies. This can be achieved by those studies can be saved and reloaded later on to run those optimization processes again. I have created one which I'll load it. I've created one in a former session. I want to go with you through these steps. The first, what I want to achieve, that in my current scenario I want to get a resulting Excel sheet where I get all the details about the solving process. So we're starting with the objective method. This can be selected very simple. It should be a target value or a minimum in this case. And the objective in my scenario is not an expression, it's a geometric scenario. And therefore, I want to select from my solid body I have to remove it first, otherwise I cannot select it. I want to have a minimum for a geometric element, and this geometric element should be my surface of my solid body. Okay. Then the variables, I have my two parameters which should be varied through iterative processes with setting up lower and upper limits to avoid unexpected modifications which are out of range of other constraints. Then I have a major constraint, which is in this case also a geometric one. I will show you how to select this, select the solid again, and then it's a volume, and the constraint type should be lower limit. That means that if we start from a very large can, the idea is that the limit will not under the target value of this volume. That means in my case we'll change the limit value now to 1000 cubic millimeters, and that's for setting up. Now I will run through into the solution. Therefore I close all this and go into the algorithm system. Be aware that you choose one of the best iteration problems which will most to your problem or intent, and in the help file of NX there is a description about the different solving strategies available. What are the different strategies can achieve? Especially I will often use the global simplex one because I often do not know exactly where my solution will be found, if it is close by my current design or far away. Therefore I take this global simplex. Then the next one is algorithm details. I will set it to fast, and I will adjust a little bit the tolerances to making not too large, the reducing the required accuracy. And I also want to have the Excel file open because I want to check if it is comparable, the result, to the Excel solution. Okay, I will now run the optimization process. And now you see how the system is updating the individual expressions, and if the solver has found an area with this global simplex strategy where it seems to be a solution available, he steps into the details and tries to optimize different variables much more closer. In comparison to the Excel-based solver, this NX integrated one is very useful if you have more complex design, which radius and so on, because those geometric formulas cannot be included in Excel, and on the geometric base of NX you can use those mechanisms. So let's check the result in Excel. It is very close by the target volume, while the entire surface is nearby the solution the Excel solver has found out. This is the, let's check the value, what it is. The diameter close to the Excel calculated base, and the height seems to be a little bit different, but the accuracy is, the target was addressed more closely. And you have the possibility to save those studies and run those studies multiple times, also with different strategies to find the optimal design by iterative processes.